Yeah, that was good. That was a good problem. All right, okay, let's go to problem 3. Let's just do it. Problem 3 is a molarity problem. Not converting between the two necessarily, although you will. There is a part that we will have to do that. But calculating both of those, we're going to calculate both of them, given some information about a solution, an acid solution. Okay, let's do it. I love this. This is great. Problem solving makes me whole. Woo! Okay, problem 3. Problem 3 is that the concentrated sulfuric acid solution that we use in lab is 98% H2SO4 by mass. Okay, now 98% H2SO4. 90%. What's the other 2%? Water. 2% water. Which one's a solute? Which one's a solvent? It's kind of a trick question because I had gone over earlier in a couple of videos ago talking about solution terminology. I said the general guideline, and I didn't say rule. General guideline is that the one you have the most of is your solvent. The one you have least of is your solute. Not in this case. When it comes to acid-based solutions, water is always, I repeat, water is always the solvent. Even though I don't have very much of it by mass here, it is a solvent. That's dissolved in you. Boy, that's a lot of that and a little of you. That's super concentrated. This is concentrated sulfuric acid. So this stuff, it comes in, we order it from chemical plants. We get them from Fisher Scientific or Sergeant Welch chemical supply companies, and it comes in 98%. This is super concentrated. And if we want to use it, we typically don't use the concentrated stuff. We dilute it down to whatever dilution that we need. Now, it's usually around 19 molar. 18 molar, 18.3 if I remember this one right. I'm going to cheat and look at my answer. It is 18.3 brain. It's getting late, people here. It's almost 4 o'clock in the afternoon, and I got to get back and have a Zoom meeting with you pretty soon. So let's get through this one more problem. We'll call it a day after this problem. All right, now, well, I mean, not for the whole day. There's more stuff that we'd have to do for today on our list, but I mean, like literally for this day, I'm calling it a day after this problem. You with me? Let's go. All right. So this acid solution comes in as 2% water. Even though it's only 2% water, that is your solvent. This is our solute. And we're going to solve for the molality and molarity of this solution of this acid. The molality is actually easier for this problem. The last problem, we went from molarity to molality, and that was like, oh my God, this problem's hard. This time, we're actually going to solve for molality pretty quick. It's the easier of the two. Let me show you why. This is moles. Moles of the H2SO4 divided by kilograms. Remember, molality is kilograms of the water, because that's my solvent. It goes on the bottom. Okay, so it's pretty quick, actually, to do this problem, but we have to realize something. We can't do it. We don't have mass, and we don't have moles, and we don't have mass to get the moles. We can't do this problem. Billy, calm down. That's angsty Billy again. Yes, we do. It's right here. Those are our grams. No, they're not. They're percentages. Those are our grams. No, they're not. Yes, they are. Yes, they are. Let's assume, and we can sometimes assume, actually, even though the saying goes we can't, or we shouldn't, we can assume 100 grams. If we had 100 grams of this acid, 98 grams of it would be the H2SO4 and 2 grams would be the water. Turn the percents into grams, just make them grams. You can't do that. Yes, you can. We're assuming 100? Well, what if I had 9,872 grams of the acid? Okay, and when I'm done with this video, you can go back, make up any number you want for what the total mass is of the acid. Then take 98% of that total, use that for sulfuric acid, and then take 2% of that total and use it for the water. You will get the same darn thing. No, you won't. Yes, you will. Okay, once again, Billy, so angsty. 98 grams, 2 grams. That's what I'm going to use. Okay, we're assuming 100 grams. So now, 98 grams of sulfuric acid, that can be converted into moles. Mass to mole conversion. Never goes away. Got to know how to do it. So 98 grams of H2SO4, let's convert that and put that into moles. I'm giving up on the pointing thing. I'm never going to remember two fingers, okay? Sorry. No offense, no offense. I just never remember it. So one finger, two finger. Grams of H2SO4. Okay, grams to moles. One goes next to the mole. From the problem before, or was it two problems ago? It was two problems ago. Problem number one, I gave you the mass of sulfuric acid. We gave you the mass of H2SO4. Add those up, you get 98. Okay, so 98 goes down here. Let's do the math. 98 grams divided by 98, multiplied by 1. 98 divided by 98. Anybody have a calculator? Anybody? Michelle, could you? What do you get? 98 divided by 98. Yeah, 98 divided by 98. 1? Okay, 1. Okay, I'm trusting her. Trusting her. 1. So this comes out to be 1 mole of the H2SO4. So to get molality, 1 mole of H2SO4 goes on top. And then we need kilograms of the water. Grams of the water is right there. We already got grams, 2 grams. Make it kilograms, put it down here. How do we get grams to kilograms? 3 places to the left. 0.002, 2 grams to 0.002 kilograms. Boom. We now have moles divided by our kilograms, and 1 divided by 0.002 is 500. This comes out to be a 500 molal solution, which is super, super, super concentrated solution of the acid. Okay, you wouldn't want to mess with this. No, you wouldn't. Super concentrated. You want to get rid of a hand, stick in some concentrated sulfuric acid for a little bit. That'll do it. Okay. Don't try that at home, for professionals only. Okay. So that is the answer, half the answer to the problem. We got the molality calculated. Let's calculate the molarity. Okay. So let's see. Well, I'll leave this here. And we'll go molarity. Well, that's equal to the same thing on the top, moles of the solute. Now we already, so these have the same top, moles of the solute. So we have that already. Moles of the solute is 1. It's 1. Ha ha, huh? Pretty quick. We need volume. We need volume of the solvent. Sorry, solution. This is the kilograms of the solvent. Kilograms of solvent, we got. The volume in liters of the solution, we don't have. How are we going to get that? That's where that density comes in. Remember from the last problem? Density is going to be my gear changer. It has mass and volume in it. So if I know one of them, I can figure out the other one. So let's look. I was told in this problem that the density of the solution is 1.83. So let's see. Oh, I don't need this anymore. So density is mass over volume. The 1.83 grams per milliliter is my density of the solution. Solution, it says. And that's equal to mass of the solution over the volume of the solution. Okay, was I given either of these? Was I given the volume of the solution? No, you weren't. In fact, that's what you want to find, though. Because remember, we need volume. We need volume of the solution. On the bottom here, we need liters of the solution. So if I can get the volume in liters of the solution, I'll put that in here. I need the mass of the solution to do that, though. We don't have the mass of the solution. Yeah, we do. In fact, I just kind of erased it there, didn't I? I just realized I erased it. You had 98 grams of solute and 2 grams of solvent. Yeah, solution is a combination of those two, right? Solution equals solute plus solvent. 98 and 2, 100 grams. We had 100 grams of the solution. So there's the density of my solution. The mass of the solution is 98 plus 2, 100 grams. So this is 100 grams of solution. Okay, we have the solute and the solvent put together, 100 grams. Solve for volume. I want to move this here. So volume is equal to 100 grams divided by, switching these. I say switching, and that's what you're really doing. Your math teacher wouldn't like that. Your math teacher would say, well, divide each side by 1.83 and then multiply each side by volume. You're switching those. So I'm bringing the 1.83 grams per milliliter down, and I'm going to divide. So 100 divided by 1.83, the grams will cancel. They will. This is the same thing as multiplying by the reciprocal. So grams on the bottom equals grams on top. So we'll cancel. So go ahead and do that, and I'll get volume in milliliters. I'll get the volume. Remember, this is the solution. This is the density of the solution. This was the mass of the solution. I'm going to get the volume of the solution, which is exactly what I need here. The volume of the solution. Yes. Oh, this is so awesome. Oh, so much you want to do a happy dance. So 100 divided by 1.83 equals 54.6. 54, you don't believe me. There it is. 54.6, okay. 54.6. But try these at home. Follow along. 2 fingers, follow along. So 54.6 milliliters. 54 milliliters. I need to take that 1, which was the moles of my H2SO4, and divide it by the liters of solution. Milliliters to liters, 3 places to the left. 1 divided by 0.0546. That'll do it. That will do it. See what we get. This will give me my molarity. 1.0546. Better come out to be 18.3. Because that's what it comes in from the chemical supply companies. That's the concentration. Yes! We're good. We're good. We're good. 18.3. Yes, that is the molarity of that solution. Yeah, those 2 problems, problem 3, 2 and 3, the hardest problems out of all of them this week. No question. No question. Especially problem 2. It's the first time we've ever seen anything like that before. My guess is probably the first time. This one maybe not quite as bad, but still, I mean, it's not a cakewalk. Some problems are easy and some aren't. It's the way life is, you know. It's the way chemistry is. So that would be problem 3. We have 2 more problems to solve, but before we do those 2 more problems, we have to go through some theory again. Okay, so we've done the theory for these problems. More theory.